Okay, good morning to all of you. I welcomes to all in our lecture series on mathematical physics, that is your core paper 8, belongs to your 4th semester BSc syllabus. In our last class we have been discussed a complex integration, that is your z dz. The closed curve is C around contour C. Okay, here C is belongs to three contours: C1, C2, C3. C1 is this one, C2 is this one, C3 is this one. So in detail we have been discussed, and at last I have been given to you one question that you have to do by yourself. The question was, evaluate Z bar or complex conjugate of Z along the following contours as shown in the figure. Here this is the same contour C1, this is C2, this is C3. So what we have to evaluate? Integration of Z bar dz or complex conjugate of Z dz. Here I am explaining, you just watch it. Here the contours are C1, that is a contour from z equal to 0 to z equal to 1, then z equal to 1 to z equal to 1 plus I. See, this point is z equal to 1 plus I, right? And then C, contour 2, from here to here, then here to here. So z equal to 0 to z equal to I, and z equal to I to z equal to 1 plus I. This is the contour 2. Contour 3, C3, is z equal to 0 to z equal to 1 plus I. Okay, this is the point. This is the point belongs to real and imaginary part. But if we are going to write what is the value of the z, it will be 1 plus I at this point. Okay, so this is the okay. So here z bar is nothing but x minus iy, and z equal to x plus iy, dz equal to dx plus I dy. So here, if first we have to consider contour 1, this one. Okay, the contour 1 z bar dz is nothing but contour 1 x minus iy into dx plus I dy. That is your dz value is dx plus I dy. So you just multiply these two, we can find x dx plus I x dy minus I y dy plus y dy is equal to, this contour is nothing but z equal 0 to 1, z equal 0 to 1, integration z equal 0 to 1, this one. Okay, plus this contour C1 is divided into two line integrals, from here to here, then from here to here. Okay, so C1 is nothing but z equal 0 to 1, this one, plus another line integral z equal to 0, z equal to 1 to 1 plus I, this one. Okay, here I marked a star. Here you have to write something, this one you have to write. Now you have to write, okay, whenever you have to be familiar or you are going to be practice over this, then no need to write. That means what is the changes, which one is the constant, what will the value the 0, like that. Here along z equal 0 to z equal to 1, that means here this along this, which one is changes? X is changes, y value is 0. So if y value is 0, dy equal to 0. So y 0, dy 0 only, but x changes from 0 to 1. Now from z equal to 1 to z equal to 1 plus I, along this path or along this line, which one is the changes? Y changes, but x value is how much? X value is 1. X value throughout this line, from here to here, x value is 1. However, y changes from 0 to 1, right? So these things you have to write over here. Okay, then you have to write these things. So now this one, you consider this one, that means the line integral of this one. Along this, y dy both are 0. So this term is going to cancel, this term is going to cancel, this term is going to cancel. We are going to find x dx, the limit is 0 to 1 because x changes from 0 to 1. Okay, now you consider this one. This one means, that means z equal to 1 to z equal to 1 plus I. 1 to 1 plus I. Along that path, dy changes, however x is constant. X is constant, so hence dx equal to 0. Wherever the dx, this term will be 0, dx is, this term will be 0. Here x can be put as 1, so it will be I dy, this term will be y dy. Okay, these two terms is going to be 0 because dx is there. So we found, and the limit will be 0 to 1. Okay, y changes from 0 to 1. So 0 to x, 0 to 1 x dx will be integration. If we are going to do x square by 2, 0 to 1, this integration will be I y plus y square by 2, 0 to 1. Just put the limit, we are going to get 1 plus I. Now we have to consider C2 path. C2 path means z bar dz. Just you write it, traditionally you write, then after whenever you are going to familiar, may you are not going to write, no problem. So z bar dz is nothing but x dx plus I dy minus I y dx plus I y dy. C2 is nothing but this one, z equal to 0 to z equal to I, again z equal to I to z equal to 1 plus I. So here z equal to 0 to I, this one z equal to 1 to, here I mistake, z equal to I to, z equal to I to 1 plus I, z equal to I to 1 plus I is this one, right? So here along z equal to 0 to z equal to I, that means along this path, which one is the constant, which one is the 0, you just see. Here x is 0, x is changes, no, x not changes, x value is 0, x value is also here also 0, so dx obviously 0, y changes 0 to 1, right? So along z equal to 0 to z equal to I, x equal to 0, dx equal to 0, but y changes from 0 to 1. And along z equal to I to z equal to 1 plus I, along this path, which one is the constant? Y is constant, y is not changes anything, y1, here also y1, but x changes from 0 to 1. So here y if constant, dy will be 0. So along z equal to I to z equal to 1 plus I, y equal to 1, dy equal to 0, because y is constant, x changes from 0 to 1. Just we have to substitute these informations over here. Along 0 to 1, 0 to 1, x equal to 0, dx equal to 0. That means this term is going to cancel, this term, only y dy will be there. So 0 to 1, y changes from 0 to 1, y dy. Okay, next come to here. Here y is constant, but dy is going to be 0. If y is constant, so dy term is going to be 0. And here y is value is 1, we have to put over here, then we are going to get 0 to 1, because along this path x changes from 0 to 1. So 0 to 1, x dx minus, here I have to substitute y equal to 1, it will be I dx. Now we have to simple do the integration, you can find 1 minus I. Okay, so now we have to consider the path C3 or contour C3, z bar dz, that means z equal to 0 to 1 plus I, direct this along this line. This line equation is what is the equation? That is this is the equation of y equal to x. Okay, so C3 contour is nothing but z equal to 0 to 1 plus I is this much. Here along z equal to 0 to z equal to 1 plus I, the curve is a line having equation y equal to x, that implies dy equal to dx. And x and y varies from 0 to 1. X varies from 0 to 1, y also varies from 0 to 1. So this whole equation can be transformed either y, only y, or either only x. Here I transformed all the terms to x. Okay, so C3 z bar dz, here 0 to 1, x changes from y 1 to 0, 0 to 1, y also changes from 0 to 1. So 0 to 1, here x dx, I x, dy all equal to dx, so x d I x dx, here I y means can be written as x I x dx, here x dx minus I x dx plus x dx. So this two term is gone cancelled out. We found 2 x dx plus x dx, 2, 0 to 1 x dx 2, then integration will be x square by 2, 0 to 1, 2 into 1 by 2 equal to 1. So here we found that integration of z bar dz will be integration of c1, c2, c3. What will the value? The values are, this is one value, 1 minus I and 1 plus I, and another is 1. So here that implies integration z bar dz will be equal to 3. 1 plus I plus 1 minus I plus 1 equal to 3. But here all are different. Why all are different means it is not analytic. That we have to verify by Cauchy-Riemann equation, that is your del u by del x equal del v by del y, del u by del y minus del v by del x. Just z bar is nothing but x minus I y. You just find out del u by del x, this will be 1, del v by del y minus 1. Here del u by del x not equal to del v by del y. So hence it has been verified that z bar is not analytic. Only for that along different path or along different contour it is given the different answer. Okay, now we have to go for another question, very simple question, that evaluate z mod square around the square, the vertex 0 0 1 0 1 1 0 1. That means along this contour what will the value of this one. Okay, see, z is nothing but x plus iy. Z mod x square plus y square root over. Z mod square is nothing but x square plus y square. dz equal to dx plus I dy. So the integration, contour integration, z mod square dz will be equal to total integration or total curve along whole curve. This is the whole curve. X square plus y square, that is z mod square dz equal to dx plus I dy. Just multiply both. We can get x square dx plus I x square dy plus y square dx plus I y square dy. So we just segregate this whole curve. This whole curve is addition of four curves. What are the four curves? C1, C2, C3, C4. So this C is addition of this four contours or four curves or four lines, you can say, no problem. So it will be C1 x square dx. Why here I written directly, you just watch. Along C1 which one is changes and which one is constant? See, along C1 y value is 0. So obviously dy equal to 0, only x changes from 0 to 1. So here wherever the term y dy, here dy, here y, here y dy, both is there. So these three terms will be equal to 0 along C1. So only one term is going to be left, that will be x square dx along C1. Now along C2 you can found x is constant, y changes. X is constant means dx is going to be 0. So x value will be 1, we have to substitute. So dx, wherever the dx is going to be 0 0, and here x equal to 1 means this will be 1. So here we have to substitute 1, this term will be I dy, this 2 term is going to be 0, and this term I have written as such I y square dy, because along this curve or along this contour y changes. Along this C3, which one is changes? X changes, but y not changes. Y here 1, at this point also 1, y not changes, only x changes from 1 to 0. X changes. So if y constant along this path or along this contour or along this line, so obviously dy will be equal to 0. So dy terms is going to be cancelled out, this term is going to be cancelled out, this term is going to be cancelled out, and y value is 1. Here we have to substitute y value 1, then we can found this term x square dx, and here we have to put 1, it will be only dx along C3 path or along contour C3. Now we have to consider C4. Along C4 means along this path, which one changes? Y changes, but x is constant. X is 0. Along this path x is 0. So x is 0 means dx also will be 0. Only y changes. So what are the term x dx is going to be 0. This is going to be cancelled out along C4. So along C4 only one term is going to be left, that is I y square dy. Okay, then here we have to put the limit, that is important. Along C1 what is changes is x. So x changes from 0 to 1. So limit, lower limit to 0, upper limit 1. Here along C2, what is changes? Y changes. That means 0 to 1. Here 0 to 1. So limit will be 0 to 1. But along C3, that is important. Along C3, which one is changes? Changes is x. But from what to what? From 1 to 0. So limit, lower limit will be 1, upper limit will be 0. 1 to 0, right? Along this path, C4, what is changes? Y changes, right? Y changes from 1 to 0. Okay, y changes 1 to 0. So lower limit 1, upper limit 0, I y square dy. Okay, now you just integrate. Simply you have to integrate x square dx. It will x cube by 3, 0 to 1. Here this will be, I can be taken outside, dy. Y, this y square means y cube by 3, 0 to 1. Here here it will be x cube by 3 plus 1. X cube by 3 plus 1 means x, but limit is 0 to 1 to 0. Okay, for this case it will be I y3 by 3, 1 to 0. You just put the limit, it will be 1 by 3. This will be I 1 plus 1 by 3. This is 1 by 3. Okay, 1 by 3, and this will be 0 means 0, minus 1 we have to put means it will be minus 1 by 3 minus 1, minus 1 by 3 minus 1. This will be also minus I by 3 by substituting the lower limit, because you have to put 0, it will be 0, minus 1 we have to put means it will be 1, minus 1 by 3, so minus I by 3. So here you can see plus I by 3 minus I by 3 got cancelled. Okay, and 1 by 3 plus 1 by 3 minus 1 by 3 also got cancelled. Here only left terms are minus 1 and 1 I. So answer we found that minus 1 plus I. This is your answer. So here one question I have given to you that you have to do by yourself. In the next class we are going to discuss. This is the complex conjugate square. Complex conjugate square. Okay, and this is changes from z equal to 0 to z equal to 2. First path z equal to 2. Okay, 2 means 2 plus I0. Z equal to 0 means 0 0. Okay, then from here z equal to 2 to z equal to 2 plus I. 2 plus I means towards this you have to go up to 1. That means this point will be 2 1. If this point will be 2 1, then z belongs to z will be 2 plus I. So along this path you have to find out the integral of this one, 0 to 2 plus I. So here z bar square, z bar we know that x minus iy. So x minus iy square, you have to put a plus b whole square formula, and you have to do it by yourself. In our next class we are going to discuss. Thank you so much for watching this video. I suggest that you have to watch carefully and pause the video, write down the note in your note. Okay, thank you so much for watching this. Thank you.